All right, well, here we go with the video. So I'm going to start with this problem because maybe, Jonathan, you did not see this because I wasn't sharing the right screen. And so next time, try to tell me that in the chat. For the rest of you, go ahead and fast forward to wherever we left off to the end of the video. All right, so next time I will share the correct screen. Ugh. So anyway, we're trying to show that these two things don't intersect. So basically this process that we did up here, we want it to fail. But we still start the same way. We start with, we set them equal to each other. So the x's have to equal each other. So 2 has to equal -1 plus mu. That's a 2. -1 plus lambda has to equal 1 minus 3 mu. And let's see, 2 lambda has to equal 1 minus 2 mu. So when we do this, since this top equation doesn't have two variables, I definitely want to use that. So I'm going to use these two equations here and bring them over there. So this one I can solve for mu right away. So that tells me with those two problems, mu is equal to 3. So I'm going to plug that into this other problem here. So I get -1 plus lambda equals 1 minus 9 now. And so that's -8 plus 1. So lambda equals -8 plus 1 would be -7. All right, so now I'm going to go and use those. So I would put lambda -7 up in the top, so 2. If this is -7, that would be -8, and -7, so -14. And then down here below, mu is 3, so that would get me a 2 again. I would get 1 minus 9, so -8. So these should work, because those are the two problems, the two equations I used. But the last one, what's going to happen is it doesn't work. Put a 3 in there, I get 1 minus 6, so -5. So see that mismatch right there? That means that these things are skew. And the reason that they are skew and not parallel, we should have looked earlier at parallel. You know, parallel vectors would have the same or multiple directions. Like the direction vectors would be multiples of each other. So the direction vector for this guy is 0 because there's no variable here, 1 and 2. The direction vector for L2 is 1, -3, -2. So they're not parallel because these are not multiples of each other, and they don't intersect, so therefore they are skew. All right, so now on to equations of planes. So when you have a plane in space, you need something perpendicular to it. You know, if you have a line and you know that line is on the plane could fit up against that line in lots of different ways. And so only one thing is perpendicular. Like if I hold my hand right here and I tell you that this is on there, well, my hand could be rotated around that, right? But if I tell you that this vector is normal to it, it's only going to fit up against it one way, in a 90-degree way. So we need what's called a normal vector. A normal vector is a perpendicular vector, something perpendicular to the plane. All right, so that's going to be our A, B, and C here. And then we're going to need a point on the plane to kind of ground it in a way. Okay, so here's the formats for the equation of a plane. You can do it like this: A, x minus x1 plus B, y minus y1 plus C, z minus z1 equals 0. So that A, B, C is your direction vector, but now the direction is the normal vector. And then x1, y1, z1 are the as a point, any point on the plane. All right, so when you multiply this out and clean it up, it looks like this: ax plus by plus cz equals d. So we'll talk about that in the next example. And another way you could see this last one written is this: abc dotted with x, y, z to produce d. So this is just another format of the second one, so you see it that way sometimes. All right, so let's see. So down here, so I have 3 points on a plane, and so I need to make up two vectors out of these things so I can do their cross product. So finding an equation of a plane is kind of annoying because you have to find the cross product a lot of times if you don't know the normal vector. So we're going to make up a vector. We're going to make up this vector u and this vector v. So you can use any 3 points in any way you want, but you know, this is kind of labeled pretty nicely. So we're going to make up this vector right here from 2, 1, 1 to -2, 1, 4. So that vector right there, -2 minus 2 is -4. 1 minus 1 is 0, and 4 minus 1 is 3. So that's vector u. And then this vector right here, actually vector v. That one is going to be 0 minus 2, so -2, 4 minus 1, so 3, and 1 minus 1, so 0. again, it doesn't really matter like which 3 points you use. You just need 2 vectors using the points. Okay, so we have to come over here and we have to find a normal vector to these things. We have to find something perpendicular to both of them. So that would be a cross product. So I, j, k, and you can put them in any order because nobody's really telling you how to do it. I'll put that one first. Okay, so here comes our cross product. Cross off letter I, 0 minus 9, so negative 9. Cross off j, so 0 minus a negative 6, so that'd be positive 6, but then I change it to a negative. And then cross off the last one, I get negative 12 minus nothing, so negative 12. Okay, so we're going to go ahead and use this first basic equation. I have my normal vector, so I'm going to be using the equation. Oh, it was right there. Sorry, this one right here. And I'm going to show you a little trick to get to the second one. So we're going to take negative 9 for my a, right? My a right there. And then x minus, and you can use any point. It doesn't matter any of these points. So I'm going to use 2, 1, 1. So 2 minus 6, y minus 1, minus 12, and z minus 1 equals 0. All right, so watch what we're going to do here. We'll work it out. We get negative 9x plus 18, minus 6y plus 6, minus 12z plus 12 equals 0. Let's clean this up. Negative 9x minus 6y minus 12z. And put everything else on the other side. Let's see, 18 and 12 is 30, plus 6, so 36. So I move it over, it's going to be a negative 36. Okay, and of course you could change this, make everything positive or whatever you want. Actually everything divides by 3 really nicely, so you could do that too. But anyway, this is my equation, my plane. So this is kind of a lot of work and it's kind of annoying. Well, we could have just gotten the answer straight away to this version right here if you realize that this d value right there is just the dot product of the normal vector and a point on the plane. Okay, so because that's what we were doing. Look, 9 and 2, 6 and 1, 12 and 1. So we were just really dot producting this guy with that guy. That's how we were getting that number over there. So if I would have done this, just realized my cross product, my normal vector, negative 9x minus 6y minus 12z, and then just mentally do the dot product of this guy with any one of these points. It doesn't matter which one. So look, negative 18, negative 6, negative 12 adds up to negative 36. I get the same answer a lot quicker. Or look at this, 0, negative 24, and negative 12. Hey, negative 36. Or this one, 18 minus 6 minus 48 adds up to negative 36. Okay? All right, so that's that. That's where we got to in class. So I'll see you next time. Bye-bye.